All right, hi everyone. I am going to go through the notes on Intro to Chemical Reactions with you via video this semester. So you will need to have a periodic table handy and your notes so that you can follow along. So first and foremost, whenever we're talking about chemical reactions, the main thing to keep in mind is that we have the law of conservation of mass and matter that we have to abide by. Matter can't be created or destroyed. It's not allowed. There's a law against it. It is always conserved. So when we write chemical equations, they're going to be written so that we abide by this law. We'll learn more about how to make sure that our equations are balanced later this week. Alright, so what's really happening during a chemical reaction? Well, essentially during a chemical reaction, bonds are being broken. So if you look at these starting materials, I've got different colored circles representing different elements, and you have the blue and the yellow that are attached, and the pink and the red. When a reaction happens, atoms are rearranged after those bonds are broken. So we have the blue and the red now, and the pink and the yellow. So new compounds are being formed, and these new compounds have new properties to them. So anytime a chemical reaction is happening, you're forming a totally new substance. You're not just changing states, new things are forming. Okay? So regarding chemical changes, you learned about properties of matter and back at the beginning of the semester, and you were looking at what were considered chemical changes versus physical changes. So some of the signs that you have a chemical change happening are when you have a change in the heat or light. So you react something and you see light given off. We described how in the body of a firefly, a reaction is happening so that a particular molecule is excited and then it releases a photon of light when it relaxes. So by giving off light, that is considered a chemical reaction. If it gives off heat, it's considered exothermic. Exo means outward, therm is heat, so it gives off that heat. Endothermic is it absorbs heat, so it's going to feel cold if it's endothermic. There are some reactions that when you mix the two substances together, they get cold. Sometimes they get hot. Okay? So that change in heat or light is definitely a chemical change going on. Sometimes you have a formation of a gas. So a gas is given off. This is different from if something is boiling. Boiling is just a change of state. But if you've got two room temperature substances and a gas is being given off, often that is a sign that a chemical reaction is happening. Next one, formation of a precipitate. This is the first time we're hearing this word. Precipitate is when a solid is forming out of a solution. So if you have two aqueous solutions, that means all the solutes are dissolved up, and you mix them together. Sometimes a solid will form. That solid is essentially an insoluble salt. It does not dissolve in the solvent, the water, and that precipitate is a new substance, different from the initial reactants. Okay. Lastly, on this list, we have a color change. So if you have a reaction where one substance changes color entirely, that's going to be a sign of chemical reaction. This list is not exhaustive. This list is just an example list, so you could possibly have other ways to determine that a chemical change has happened. All right, so we're going to use chemical equations. This is the first time you're really seeing chemical equations. We've learned how to identify elements with their symbols. We have learned how to write chemical compounds out into their formulas. Now we're going to take those formulas and put them together in chemical equations. And equations in chemistry are a little bit different than the equations you see in math. We do have something like A plus B, but instead of using an equal sign, we use an arrow indicating the direction of the reaction, and it yields C plus D. So these symbols, these are considered the reactants. They're on the left side of the arrow. On the right side of the arrow is the products. Now, we can write the arrow the opposite direction, but we don't typically go right to left. But you can and will see reactions written that are going from right to left. It's just not the conventional method. All right, so let's look at an actual equation and identify these pieces. So here's an equation where we have 2 molecules of hydrogen gas and we have a molecule of oxygen gas, and it's reacting, this arrow, to form 2 molecules of water, of course. There's some pieces in here that we need to identify. So you see this first one up here that says coefficients. The arrows are pointing to the giant numbers out in front of the formulas. There isn't an arrow pointing out in front of the oxygen. So we've got 2, and we imply that a 1 is here. It's not written in because sometimes we like to cut corners. So it is an implied 1, and it is yielding 2 molecules over here. So the coefficients are written out front. We have these arrows are pointing to subscripts. We could also have an arrow pointing here and here. Subscripts are very different from coefficients. We'll talk about that in a second. So we've got over here on the left side is the reactants. We've got on the right side our products. We can have 2 reactants forming 1 product. We could have 1 reactant forming 2 products. It's all dependent on what kind of reaction is going on. We've got the yield sign is what our arrow is called. Yield meaning to form or to produce this product on the right. All right, let's look at more about what these coefficients mean. So first off, I just showed that coefficients go in front of the compound. We've already learned that subscripts tell you how many of each atom are in that particular unit. So I've got a picture here where I'm showing in this calcium fluoride compound 1 calcium in blue, 2 fluorines, the white circles. So this is if the coefficient out front was a 1. There's a single calcium and 2 fluorines making up this 1 unit of calcium fluoride. If you put a coefficient out front, coefficients tell you how many molecules are in that particular equation. Coefficients are not, how do I say it? They are unique to the particular reaction that is occurring. So the coefficient that goes out in front of calcium fluoride is not always a 4. But calcium fluoride is always going to be 1 calcium and 2 fluorines. So coefficients can change, subscripts cannot. When I have this 4 out in front of CaF2, that just means I have 4 units of calcium fluoride. Okay? So subscripts, I have to keep those the same regardless of what reaction I have. But coefficients, those can be different depending on what reaction I have. Okay? So coefficients and subscripts, really getting this clear out there. Coefficients can be changed in order to balance an equation, okay? But you cannot change subscripts. Subscripts are the identity of the molecule, okay? So if a subscript is changed, you completely change the identity. For example, H2O versus H2O2. They are not the same compound. There is a joke out there about H2O and H2O2. Go find it. It's pretty good. Okay. So by changing the subscript of oxygen, you go from having water to having hydrogen peroxide. Water is not deadly? Well, it is, but H2O2, you probably don't drink it in your water bottle every day, right? Very different. All right. So coefficients can be changed, subscripts cannot. All right, so we're going to use some pictures to describe an equation. This is, right now, it might be a good time to pause if you have some colored pencils or some other writing device that is different colored. You can also use different shading, different shapes, whatever you want to do to show the different elements in each of the substances. All right, so if I'm going to use pictures to describe an equation, I'm going to use different colors. So for aluminum, I'm going to have a color specific to it. sodium, and the chlorine. So in aluminum, there's only a single atom. There's no coefficient out front, so I'm assuming it's 1. For the NaCl, I see that there are 3 NaCls. And within NaCl, it's 1 sodium and 1 chlorine. So if I'm going to draw this picture out, I'm going to have my 1 aluminum atom, and I have 3 sets of sodium chloride. Okay? Then as this reaction is proceeding, I see that now in my product side, sodium is by itself, and I have aluminum paired up with the 3 chlorines. So that means I'm going to take the red is what I've used for sodium. So I'm going to have 3 solo sodium atoms. And then I'm going to take that aluminum and I'm going to pair it with the 3 chlorine atoms. So I have this. And it should make sense that this is the order that I should be, or this is the formula I should end up with, because aluminum is a +3, chlorine is a -1 charge, there's 3 chlorines, and a +3 for aluminum. So all the charges add up. So being able to name your compounds is pretty important. Then I can go and count things up. I see that on the reactant side I have 1 blue, I have 1, 2, 3 red, and I have 1, 2, 3 yellow. On the product side I have 1 blue, I have 3 red, and I have 3 yellow. This equation has been balanced for you to begin with. The coefficients are already there, but eventually we're going to get to where we have just the reactants, and I will have you predict what the products are and then balance the equation. Okay, so that's looking forward. But in the end, the number of each kind of atom has to be equivalent on the left and the right side of the arrow. Alright, so this next practice problem, if we have zinc plus 2 HCl molecules making zinc chloride and a hydrogen gas molecule, what I have to look for is what are the coefficients and what are the subscripts, and then what kind of elements I have. So I see a zinc all by itself, I see hydrogen and chlorine, and there's 2 sets, and I see a zinc with 2 chlorines. There's only 1. And I see that 2 hydrogen atoms are attached to each other. Remember something about diatomics? I'll get to that in a second. So I have 1 blue atom for my zinc. I have the red and the green to represent a hydrogen and a chlorine. And I have 2 sets because the coefficient out front, there's 2. The zinc rearranges so that it's paired with the chlorine, so I have zinc and 2 chlorine, and I have the 2 hydrogens pair up. Okay. Regarding naming of these compounds, I want to make sure that we are very clear on this naming business. This HCl, since it starts with an H and 1 other element, it's an acid. Okay, and that acid, since it's just 2 elements, is going to have the hydro prefix. So I'm going to put hydro. The chlorine makes the stem chlor, and it should end with ic, acid. Okay. Try naming this one. Pause your video so you can name it. All right. So this Zn is zinc, and the Cl is for chlorine. I put an IDE ending on my anion. Zinc chloride. Now, that's not the full name. I still have to add one more piece. Zinc is what kind of element? The transition element. So I'm going to use the charge of my chlorine, which is a -1, and there's 2 of them. So since there's 2 chloride ions, that means there's a -2 charge on chlorine. That means zinc has to be +2. So I'm going to put Roman numerals 2 in the name. And then lastly, H2. H2 is one of my diatomic elements, so I just name it hydrogen. And that's it. It's hydrogen. Anytime I see hydrogen in a reaction, it's H2, not just H. You have to remember all of your diatomics, like hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, you must know these. HNOFCl, Make up a mnemonic device. Notice that they form a 7 on the periodic table, except for hydrogen, and there are 7 of them. Alright, so that's what that one looks like. One more practice on this. This one's a little bit more complex. We have 2 aluminum atoms. We have copper 2 chloride. We have copper, and we have aluminum chloride. Okay, so copper 2 means the 2 in Roman numerals. Alright, so for my 2 aluminum atoms, I'm just going to put 2 aluminum atoms, and that's it. For my copper chloride, my copper 2 chloride, if I'm going to name it correctly, I have 3 sets of them. That means every set has a copper and 2 chlorines. So I'm going to put green for my copper, and I have 2 chlorine atoms attached to each copper. When the reaction proceeds and I end up with 3 copper atoms by themselves, I'm going to take that green copper atom and list them by themselves. And I'm going to take my aluminum chloride, and I'm going to have my 2 aluminum blue atoms, each with 3 of the yellow atoms. So there it is. Aluminum chloride and copper are the products of that reaction. Alright, so there's different ways we can describe equations. Like, equations are the simple form, but we can also turn those into a sentence, words. Okay, so I'm going to expect that you are able to not only write an equation as with symbols, but also with words. Okay, so the vocabulary we're going to use is, if you have an individual element, we're going to call it an atom. If it's a covalent substance, generically covalent, as in 2 nonmetals, we're going to call it a molecule. If it is an ionic substance that has a metal and a nonmetal, we're going to call it a unit. Okay, so remember these words from when we first learned about ionic and covalent bonding. We talked about molecules that are covalent and units that are ionic. So some examples, you probably already saw them. I didn't cover up the answers already. CO2 is covalent. It's 2 nonmetals. So we're going to call it a molecule of carbon dioxide. Mg is just an element, so it's an atom of magnesium. MgO is ionic because it's a metal and a nonmetal, so we have a unit of magnesium oxide. Okay. So here is a practice problem for you. We have zinc, we have HCl, which is what kind of substance? We have zinc and chlorine, which is what kind of substance? And we have H2, which is what kind of substance? So zinc is all by itself. HCl, we've got 2 sets. We've got the 2 reds and 2 greens, a set of red and green each. After it reacts, zinc is going to pair up with 2 chlorines, and then we're going to be left with H2. So if I'm going to use the correct terminology for each of these, zinc is an element, so it's going to be called an atom. HCl is an acid. It is hydrochloric acid. It is actually covalent, so we're going to call it a molecule. And there's 2 of them, so molecules. ZnCl2, zinc 2 chloride, is ionic, metal and nonmetal. So I'm going to call it unit. And it should be singular unit. And then lastly, H2. This is an element, but because it is 2 atoms of hydrogen, I'm going to consider it to be a covalent compound. So I'm going to call it a molecule because it really is a molecule. It's 2 atoms together. So diatomic elements are covalent compounds, and we refer to them as molecules. So molecules of hydrogen, molecules of oxygen, molecules of nitrogen. Okay. All right, so some other symbols that you might see in a chemical equation. We have, obviously, the arrow. The words that we use to describe them is produces, forms, yields. Okay. The plus sign is plus, surprise, or you can call it and. When you see S in parentheses, that means it's a solid. L in parentheses is a liquid. G in parentheses is a gas. You're always going to want to specify what state of matter your substances are in. Sometimes it's essential to state what matter that particular compound is in. Down here, this is an AQ. It kind of looks funny, but AQ means aqueous. It means that the solid has been dissolved up in water. You did the ionic and covalent and metallic properties lab a few weeks ago where your sample A was aqueous. It was acetic acid, but it was dissolved up in water. So you did not have pure acetic acid. It was aqueous. Last arrow here on this sheet has a triangle over the arrow. That means that you're heating up that reaction. Sometimes it says reactant A and reactant B are heated at such and such temperature for this long. So when they're heated, the triangle is put over the arrow. It doesn't always get put there, but if you see it, that's an indicator that it's being heated. All right, so some other symbols you might see, there's an arrow downward, which means that a precipitate forms. You also would see that with S in parentheses, a solid as a product. These arrows are only in the product side. Okay. This arrow upward, a gas is being formed, so then one of your one of your products is a gas. And then also you could see arrows going both directions. Most reactions actually do go forwards and backwards. The extent to which they go forward and backward can be different from reaction to reaction. So sometimes we draw an arrow very forward and a little bit backward, or a little bit forward and very backward. So this is indicating up here that mostly products form. Some of those products then revert back to the reactants. Whereas this one is not very many products form, but most of the products that do form go back to the reactant side. This is when we have equilibrium. Okay, so some equilibrium is when the rate of products forming equals the rate of reactants forming. That doesn't necessarily mean that you have the same amount of products and reactants. It just means that any reactant that turns to product, there's a product that goes back to reactant. Okay. Last piece from this, anytime you see something above the arrow, it indicates special conditions for the reaction to occur. So you could put, if there was a catalyst, sometimes people will put on the reaction for the arrow, they'll put PT, platinum catalyst, or they might write the temperature at which the reaction occurred, or they might say the reaction was run under 5 atmospheres of pressure. So you can change the conditions for your reaction, or you can indicate the conditions by writing it above the arrow. All right, so let's try wording some equations. So here's an example of an equation. We have 2H2 G in parentheses plus O2 G in parentheses, arrow 2H2O G in parentheses. So to word this equation, I need to take all of the information that has been written out in symbol form and turn it into a sentence. So I'm going to start with this piece. I see the 2 is the coefficient. I have H2 and I have a G in parentheses. That means H2 is a gas. H2 is also a diatomic element, so I'm going to call it a molecule. And the name of this thing is just hydrogen. So there's a lot of information just in this small piece. Okay? So I'm going to start with saying 2 molecules of hydrogen gas. You could say 2 molecules of gaseous hydrogen. It's up to you. Okay. The plus sign means either plus or reacts with or and. Let's see, what did I put? I put reacts with. And then I look at this piece. There's no coefficient, so I assume it's 1. It's also a gas. It's also a diatomic element, and it's oxygen. So I'm going to call it 1 molecule of oxygen gas. So we'll get rid of this for now. Okay. So that's as far as I've gotten here. Now I've got the arrow. The arrow means either produces, yields, forms, just to make sure it's grammatically correct. We've got reacts with 1 molecule of oxygen gas to form. And now the last piece, I have 2 of them. It's gaseous, it's covalent, there's 2 nonmetals, so it's a molecule, and the name of the molecule is water. You could go so far as to say dihydrogen monoxide, but I'm not going to require it. So I have 2 molecules of gaseous water. Okay? So wording equations can be lengthy, but it's quite amazing how much information is given in this one small equation. Let's try another one. All right, so here's the next one. This is one you've seen already in our symbol form. We have zinc, we have HCl, we have ZnCl2, and we have H2. Sometimes it's a good idea to just go ahead and list all of the compounds out so you make sure that you have all the names correct. Secondly, identify what kind of vocabulary you're going to use for each of these. This is a free element, so I'm going to call it an atom. This one is an acid, and it just so happens it's also covalent, so I'm going to use molecule. This one is a metal and a nonmetal, so it's ionic. I'm going to use unit. This last one it looks like it's an element, but it's a diatomic, so it's covalent, and I'll use molecule. So I'm going to have 1 atom of solid zinc. It's reacting with 2 molecules of, I can put aqueous right here, 2 molecules of aqueous, or I could say 2 molecules of something and then aqueous. But it sounds better, aqueous with the name of the compound. The compound is an acid. Pause here to name it on your own. 2 molecules of aqueous hydrochloric acid. Arrow means to produce. This is ionic, so I'm going to say 1 unit. Pause here to name it. We're going to call it aqueous zinc. This should be zinc with 2 in parentheses. It's hard to see now. Zinc 2 chloride, and 1 molecule of hydrogen gas. So 1 atom of solid zinc reacts with 2 molecules of aqueous hydrochloric acid to produce 1 unit of aqueous zinc 2 chloride and 1 molecule of hydrogen gas. All right, so if that wasn't hard enough, let's go the other direction. How about writing the equation when given a sentence? You'll see this on the Quality Core exam. So it's not something I've made up. Okay? So we're going to take this sentence and turn it back into an equation. I see, to start with, 2 atoms of aluminum. So this 2 atoms of aluminum is a set. So I have 2. Since it's atoms, I know it's a single element. Aluminum is the formula. And when it's a metal, aluminum, we can assume that it's probably solid. Even though that my sentence doesn't say that, aluminum is not usually liquid unless it has indicated somewhere in the reaction that the aluminum is really hot. I have nowhere indicated that, so I'm just going to call it a solid. It's reacting with, so that is a plus sign, 3 units of aqueous copper 2 chloride. So 3 is my coefficient. Units is that it is ionic. Aqueous, I'll put AQ after the compound. Copper 2 chloride, I need to write my formula correctly. Copper and chlorine. Since it's copper 2, that means there has to be 2 chlorines to match with the plus 2 charge of copper. Since chlorine is a -1, there's 2 of them. To produce, arrow, 3 atoms, so 3 atoms of copper, Cu, and again, copper is a metal. Nowhere did we discuss any temperature being really high, so it's probably a solid. And 2 units of aqueous, so I'll put my aqueous, aluminum chloride. So aluminum is Al, chlorine, my chloride. Aluminum is a +3 charge. Chlorine is a -1. So that means when I crisscross, I should get AlCl3. So let me show it to you nicely and neatly. Does it all fit? Barely. So I'll go through it. 2 aluminum solid plus 3 CuCl2 aqueous yields 3 Cu solid plus 2 AlCl3 aqueous. Guess what, guys? That's it. Now you should be able to complete the homework in the homework packet, the Intro to Reactions parts, pages 1 and 2. If I am able to find a copy of it really quickly. Here it is. It is this page here, Intro to Reactions worksheet. Up here at the top, you're taking sentences and writing out the equation that corresponds with that sentence. Down at the bottom, you're going to take the equations written and write a sentence to describe it. Number 5 and 6 means you're just going to draw a diagram to represent. So the reaction number 3, we have 2 sodiums plus a chlorine molecule makes 2 sodium chloride units. You're going to use the circles and the colors to depict number 3 reaction. You can differentiate between elements using different colors, different shadings, different shapes. I don't care. Same thing for number 6. Then also Intro to Reactions worksheet 2, same deal. Make sure you're paying attention to diatomic elements. Hint, hint, chlorine gas. Okay? 3 and 4, write the sentence that corresponds with the formula or the equations. Draw it out for numbers 3 and 4. Cool? Have fun, and I will see you later.